So, hello students, we'll be starting our vector algebra chapter. So, we define first what are vectors. Vectors are those physical quantities which has both magnitude and direction. Magnitude and direction. So, these are the physical quantities which has both magnitude and direction. The common examples, some examples: velocity, acceleration, displacement, force, etc. Okay, all these vectors have both magnitude and direction, and though there are certain physical quantities which has only magnitude, they are called scalars. Okay, now we define a vector by a letter A, and the graphical representation is a straight line with an arrowhead. The length of this line represents the magnitude of the vector, and the direction is specified by this arrowhead. So we represent a vector as A with a arrow mark on the top. Okay, now we will be dealing with some of the important properties or some of the important operations in vector algebra or including vectors. First one is the addition. Addition of vectors. So how can we add two vectors? So if A is a vector, we have another vector B. Let this vector be A. How can we add these two vectors? You have studied two methods in your plus 2 classes. First one is the triangle law of addition. Okay. And the second method is the parallelogram law of addition. So how can we add by the triangle method? Vector A and vector B is kept like this, and the third side of the triangle will be the resultant of A and B, or A plus B. A plus B will be the resultant of the two vectors, or the third side of the triangle. This is one method of addition, and the second method is the parallelogram law, which says that if A is a vector and we fix B on this side, so A and B, if they are the two sides of a parallelogram, on completing this parallelogram, the diagonal of this parallelogram is A plus B. This is the resultant, and we can add either by the triangle method or by the parallelogram method. These are the two methods for addition. Now what are the properties of addition? First property is that A plus B is equal to B plus A. You can add either A to B or B to A, both are the same. Now the second property is that it is associative, that is A plus B plus C, that is equal to A plus B plus C. Okay, this is the properties of addition. Now next is multiplication. So first of all we will be starting what is the multiplication of a vector by a scalar quantity. Okay, multiplication by a scalar. So what will happen if you multiply a vector by a number or a scalar quantity? So this is a vector A. Now what is 2A? So 2A is a vector having the same direction as A, but it has 2 times the magnitude. So magnitude is multiplied by 2 along the same direction. So when we multiply a vector by a scalar, the magnitude of that vector is multiplied, keeping the direction same. So by multiplying with a scalar, the direction of the vector does not change. That is an important point. Okay. Now when we multiply a number A into A plus B, you can distribute it over the addition. That is, this will be equal to A. This is a scalar or a number A into vector A plus A into vector B. This is possible. So, this is the second property, multiplication by a scalar. Now, the third operation is the product of vectors. Product of two vectors. First one is the dot product. So dot product is defined as vector A dot B is equal to magnitude of A into magnitude of B cos theta, where theta is equal to is the angle between A and B. That is, if we add, if we multiply A with B, let this is A vector and this is B vector. A to B, this angle is theta. So this is a number, so the dot product is also called a scalar product. Okay. Now, what are the features of dot product? One feature is that it is commutative. A dot B is equal to B dot A. Another feature is that it is distributive over addition, and that is A dot B plus C. So that is A dot B plus C